Hey everyone, and welcome to This Explainer. Have you ever looked down at the street while you're out for a walk, or maybe stared out the window while driving, and just thought about the sheer amount of unseen engineering it takes to make that smooth journey possible? Well, today, we're going to unpack exactly that. We're going to deconstruct the ground right beneath your feet and reveal the fascinating, hidden architecture of our daily commutes. Let's explore how roads are built, layer by layer. It's honestly so easy to take our modern infrastructure completely for granted. We cruise along at 60 miles an hour on these smooth pavements, and usually the only time we think about the road is when we hit a pothole, right? But have you ever stopped to wonder what immense, unseen engineering is actually hiding directly beneath the surface we drive on every single day? It might look like just a flat ribbon of black or gray stuff poured over the dirt, but man, that couldn't be further from the truth. There's a whole hidden world down there.
So, to truly understand this, we're going to do a bottom-up build. We'll strip away the mystery and quickly run through the hidden world beneath us, how the ground is prepared, the foundational layers, building up the strength, the final surface, and ultimately, how knowing all this is going to completely change your next commute.
All right, Section 1. The hidden world beneath us. Let's take a look at the invisible engineering resting just inches below our feet. The absolute most crucial thing to grasp here is that a road is not a single magical layer. It is a highly complex, meticulously stacked structure. Honestly, think of it less like a carpet rolled out over the grass and a lot more like a horizontal skyscraper built downward into the earth. Every single millimeter of depth is calculated. If a road were just flat pavement poured directly on top of raw earth, the very first heavy truck that drove over it would just absolutely shatter it into a million pieces. It takes a carefully orchestrated series of materials working in perfect harmony. And whether a road is being built across a flat, bone-dried desert or winding through incredibly wet, hilly terrain, this underlying structure has to constantly adapt to survive. Moving right along to Section 2, preparing the ground. This is where we start at the very bottom, before any actual road materials are even brought to the site. Okay, the first step in any road construction is dealing with the base dirt itself. This natural ground, which engineers call the subgrade, is essentially the canvas for the layered build we're exploring. You know the saying, you can't build a strong house on a weak foundation. Well, the exact same principle applies to roads. Crews have to completely clear away all the organic topsoil. If they're building in hilly areas, this means a massive cut-and-fill operation, literally carving off the peaks of hills and filling in the valleys to create a perfectly level baseline. Once that's done, this bare earth is relentlessly graded and compacted with massive, heavy machinery. They have to squeeze every last pocket of air and moisture out of it to create a super dense, unyielding surface. Because at the end of the day, this preparation step dictates the lifespan of literally everything that goes on top of it. Section 3. The foundational layers. Let's move one step up in our structural cross-section. Once that bare earth is perfectly prepped, we introduce the subbase. This structural foundation relies heavily on robust, incredibly rough materials mixed together, specifically crushed stone, gravel, and compacted soil. Now, why these specific materials? It's because they're angular and coarse. When heavy rollers press down on crushed stone and gravel, those jagged edges literally lock together like puzzle pieces. It creates this incredibly rigid matrix. And notice the background graphics here showing water? This is a huge factor. In wet climates, if groundwater seeps up, it causes something called frost heave, which can totally destroy a road from underneath. So this porous stone layer actually acts as an essential drainage system, keeping the upper layers perfectly dry. Section 4. Building up the strength. As we move up to the middle layers, this is where the really incredible structural integrity comes into play. Here is where the absolute magic of the middle layer, the base course, happens, and it's all through load distribution. When a massive 18-wheeler drives over the road, its tires create incredibly intense, concentrated pressure on a super small area of the surface. If that downward force traveled straight down, it would punch a hole right through to the dirt. But instead, these engineered middle layers disperse that massive weight outward in a wide cone shape. By the time that downward force actually reaches the foundational gravel and the earth below, the weight is spread across a much, much wider area. It's why the entire structure doesn't just cave in. It is quite literally pure physics at work. And this really brilliantly illustrates the contrast as we build upwards. We're transitioning from the raw, heavy bulk of the bottom layers to the highly engineered, weight-bearing mechanics of the middle. The foundational layers are your rough, tough stabilizers and drainers. But the middle layers? They act as structural shock absorbers,
Much like the springs you're seeing illustrated here, they're engineered with precise aggregates to take that dynamic, moving weight and safely bounce and transfer it downward.
Section 5, the final surface. We have finally reached the top capstone of our bottom-up build. This is it, the highly refined, smooth surface layer we all actually recognize. It acts as the capstone to all those complex layers beneath it. Whether it's made of flexible asphalt or rigid concrete, this top layer has a couple of very specific, vital jobs. First off, it's got to be smooth enough for a comfortable ride, but textured enough to actually give your tires grip, especially in the rain. Second, and maybe most importantly, it acts as a waterproof roof for the entire structure. Depending on whether you're in a scorching, dry environment or a freezing, wet one, engineers will choose specific blends of asphalt or concrete to make sure this seal holds tight. If water penetrates down into those carefully compacted base layers we just talked about, it can wash them away or freeze and expand. And honestly, that is exactly how potholes are born. This top layer is the ultimate protector for all the unseen engineering below. Finally, Section 6, changing your next commute. Let's talk about what this new perspective actually means for you. I think when you truly understand this process, it completely shifts how you view the world around you. Your past view was probably just seeing a simple, flat, kind of mundane surface. It was just the gray or black stuff that gets you from point A to point B. But your future view? It's totally different. Now when you look at a road, you basically have X-ray vision. You'll visualize this deep, complex, multi-layered, engineered cross-section supporting every single journey you take. You're going to picture that perfectly compacted earth, the interlocking crushed stone, the load-distributing base, and the waterproof seal on top, all working together in silent, perfect unison.
It really is amazing just how much thought, science, and literal heavy lifting goes into something we largely ignore every day. So I want to leave you with this final thought. On your next commute, as you're gliding along smoothly, will you ever look at a mundane highway the same way again? Or will you feel that incredible hidden engineering resting just inches below your tires? Thank you so much for joining me for this explainer, and keep looking beneath the surface.